Welcome to the chapter 2 through 4 review for honors math. It's a little different because I can't use a whiteboard because I'm not supposed to be going to school, so I'm just going to do it on paper and then kind of talk you through each question. 3 people asked different questions on the review, and that's what we'll be going over. So we're going to start with the chapter 2 review and move our way forward. There may be a few out of order, but generally we'll go from chapter 2 all the way through chapter 4 in order the best we can. All right, so chapter 2 review, this is number 30. It asks you to factor, if you'll notice, 10a squared minus 13a minus 3. Now normally if this was set equal to 0, we would just use quadratic formula. And if it is on the test, do so. So if it's set equal to 0, you would just use quadratic formula. This one isn't set equal to 0, so we're going to have to factor it. So we're going to have to use the box method for factoring because the coefficient is in front of the square. The 10 is in front of the a squared. If we just need solutions or zeros, again, we would just use the quadratic formula. However, we're going to use the box method. So let's start with the box method. We set up our box. We put our quadratic term in the top left box. We put our constant term in the bottom right box. We then multiply those and we end up with negative 30a squared. You'll notice that right out to the side of the box. We know we need it to multiply to be negative 30a squared, and then we need it to subtract because of the last term by the 3 is negative. So therefore we need it to subtract to be the middle term, which is negative 13. Okay, that's important, how I set that up. Again, I got negative 30a squared by timesing the negative 3 and the 10a to get a squared together. That gave me the negative 30a squared. So it had to multiply to be negative 30a squared, and then it has to subtract because the last term was negative, the 3 was negative. Subtract to be the middle term, which is negative 13. So a lot of kids will mess this up because they'll think, okay, the factors of 30 are 3 and 10, and 3 and 10 add to be 13. The problem is you are not adding. Again, this needs to subtract to be 13. Therefore, the factors of 30 I need to use are 2 and 15. Those are the factors I want to use because negative 15 plus 2 will give me the negative 13. So again, it has to subtract or have opposite signs when added together to be negative 13. Notice that if you use 10 and 3, 10 and 3 would subtract to be 7, or you could subtract it to be negative 7, but either way you're not going to get negative 13. Then I put those in the box. So the things that are going in the other two boxes are this negative 15 and positive 2. So we have it like this. 10a squared is in the top left, negative 3 is still in the bottom right, but the two factors that will subtract to be negative 13 are negative 15 and 2a. So we put those in, negative 15a in the bottom left, 2a in the top right. It doesn't really matter. I could have put negative 15a in the top right and 2a in the bottom left. It wouldn't have mattered. Now I factor out the common factor going left and up. So if you notice, going left, I end up with 10a squared plus 2a, factoring out to the left. The common factor is 2a. Negative 15a and negative 3 factoring out to the left will be a negative 3. Always go by the first box. So the first box to the left is negative. If it's negative, you'll factor out a negative. If it's positive, you'll factor out a positive. So notice in the top two, it was positive 10a squared. I factored out a positive 2a. In the bottom ones, I have a negative 15a. That's what I'm going off of. The negative 3 really doesn't matter. So I'm going off the negative 15a, and that's why I factored out a negative 3. So that's my factoring across to the left. As I factor straight up, notice my first box is 10a squared. That means I'm going to factor out a positive, and then the common factor between 10 and 15 is 5. So I'm factoring out a positive 5a. Again, in this case, the negative 15a didn't matter because it was the second box. Factoring straight up, on the 2a and the 3, there is no common factor, so I need a 1 to hold the place. It's going to be positive because the top right box is positive. Again, the -3 doesn't really matter on the sign. So that's my factorization using the box method. That leaves me with factors of 5a plus 1 and 2a minus 3. Going on to number 39 on chapter 2 review. This one just asks a simple question, really. 16x squared minus 36 equals 0. You could just add the 36 and then divide by 16 and then take the square root of both sides, and you'll end up with an answer that is exactly the same as I'm going to get. But I noticed that this is a difference of perfect squares. So we could use factoring, we could use the quadratic formula, we could use completing the square, but because we have a difference of perfect squares, I'm going to just factor it as a difference of perfect squares. So the way I factor that is I end up with the square root of 16x squared, which is 4x, and the square root of 36, which is 6. I just put square root of the first terms in the first spots of two binomials. That's why I have the 4x and the 4x in the first spots of the two binomials. And then I have 6 and 6 in the last spots of the two binomials. It's a difference, so the signs are different. I have 4x plus 6 and 4x minus 6. Again, you could have had 4x minus 6 and 4x plus 6. It wouldn't have mattered. I set each of those factors equal to 0 and solve. So I just put 4x plus 6 equals 0 and 4x minus 6 equals 0. I subtract 6 from both sides on the one on the left and then divide by 4. I add 6 to both sides on the one on the right and divide by 4. And my answers end up being -6/4 and 6/4. I reduce those and I end up with -3/2 and 3/2. Going on to set 4-1. This one's a little out of order, but we're doing 4-1 number 56. Okay, this one is kind of interesting. So on the bottom, we just have a 2 on the top originally. And I have on the bottom two terms, the 5 and the -square root of 3. Because I have the two terms, I can't leave a root on the bottom, and I'm going to multiply top and bottom by the conjugate. So anytime you have two terms on the bottom, I have to think conjugate to get rid of a root. So I'm going to multiply by the conjugate of 5 minus square root of 3, which is 5 plus the square root of 3. So I multiply top and bottom by 5 plus the square root of 3. A lot of kids will multiply it to the bottom, but they'll forget to multiply it to the top. Multiply 5 plus the square root of 3, which is the conjugate, to both bottom and top. So we multiply that out. On the bottom, as we distribute, notice that you're going to take 5 times 5 is 25. The inside and outside terms will actually add to 0, and that's why you get rid of the root on the bottom. But I do need to multiply the last terms. So square root of 3 times -square root of 3, square root of 3 times -square root of 3 will be -3. Therefore, I have 5 times 5 is 25, minus square root of 3 times square root of 3 is 3. So 25 minus 3 is 22. Notice I didn't distribute the 2 on the top. I want to leave it as a factor that I can divide down with the denominator if possible. So I just left the 2 multiplied by 5 plus the root of 3 on the top, and then I reduced the 2 and the 22 to make 5 plus the root of 3 over 11. Going to chapter 2 review number 40. This one has 4 terms, you'll notice. There's an z cubed plus 3z squared minus 25z minus 75 equals 0. The 4 terms tells us we need to factor by grouping. So we're going to group the first 2 terms together and the second 2 terms together. Now, the second 2 terms, this is critical. You have to include the negative on the third term in the parenthesis and put a plus between the 2 parentheses. That's super important. Again, if the third term is negative, include the negative in the parenthesis and put a plus between the 2 parentheses. Okay? Now I'm going to factor out the common factor between each grouping. So the common factor between z cubed and plus 3z squared is z squared. The common factor between -25z and -75 is -25. So I factor out the z squared And by factoring it out, I mean I'm going to divide it out. So z cubed divided by z squared will leave z, and 3z squared divided by z squared will leave 3. Again, with the other on the one on the right, you'll notice that I factored out a negative 25 because 25 will divide both 25 and 75. I have to factor out the negative from both terms though. So therefore I'm dividing by negative 25. Negative 25 divided by negative 25 will just leave the z. Negative 75 divided by negative 25 will leave plus 3. So now notice between the group on the left, the z squared parentheses z plus 3, and the group on the right, negative 25z parentheses z plus 3, z plus 3 is now the common factor. So I'm now going to factor out the z plus 3, and that will leave, so I'm dividing those out to the left, and I end up with z squared minus 25 as being left. Now z squared minus 25 is a perfect square. Therefore, it can factor. Again, square root, opposite signs. So I have z plus 3, z plus 5, z minus 5, all equaling 0. Set each factor equal to 0, and then solve. You end up with z equals negative 3, z equals negative 5, and z equals 5. Remember, you can always go back and slow this down by pausing it if you need to. Number 36 on the review, somebody asked about, it's exactly the same as number 40. It's just not set equal to 0, so you'll leave it as factors. All right, going on to set 3-5, number 46. 3-5, number 46 gives you the two x-intercepts as negative 2 and negative 5. I promise you these are on the test. So x-intercepts of negative 2 and negative 5, and this is going to be needed to put into standard form, which is ax squared plus bx plus c equals y. So how do I do that? Well, if I have the x-intercepts of negative 2 and negative 5, I can write that as x has to equal negative 2 and x has to equal negative 5. I then add 2 to both sides, and x plus 2 will equal 0. Or x plus 5 would equal 0, as I add 5 to both sides of the other equation. Therefore, I can write them as factors. X plus 2 and x plus 5 should equal 0 when multiplied together. Now I just multiply that out, and I end up with x squared plus 7x plus 10. Again, first term times, this is just FOILing. And I end up with x squared, 2x plus 5x being the 7x, and then plus 2 times 5 is the 10. And that ends up equaling 0, but that would actually equal y in standard form. So just change the 0 to y to put it in standard form. All right, set 3.5, number 48. This passes through negative 5, negative 1, 0, and negative 4, 3. It's very much like the previous one, except for we're going to have a different a value, which takes us to this factored form of a quadratic with an a value. Remember, the a value is the scale factor. So on this one, we're going to have to find the scale factor. The p and the q are representing the zeros of the function in factored form. So you take the opposite sign of the zeros, much like we did on the last problem. So therefore, negative 5 and negative 1 are x-intercepts. So in factored form, you're going to have x plus 5 and y plus 1 equals, again, from that form over to here, a parenthesis x plus 5 parenthesis x plus 1 equals y. Now, this one gives us a point so we can find the y value. The extra point it gave us is this negative 4, 3. So I'm going to put in negative 4 for x and 3 for y. So I'm just substituting in the negative 4 for x in its factored form and 3 for y. Okay, so that's what we're doing there. Now, when I do this, I just plug it in and then add it before I multiply. So negative 4 plus 5 is 1. Negative 4 plus 1 is negative 3. Multiply those gives you negative 3a equals 3, because that was the y value. And then I divide both sides by negative 3. Therefore, the a value is negative 1. Now I can put it into factored form with the a value being negative 1. So in factored form, I have negative 1 x plus 5 in parentheses square, and an x plus 1 in parentheses equals y. This is the factored form, but I want it in standard form. So again, I FOIL it out. X times x is x squared, 5x plus inside term and outside term, x, 5x plus x is 6x, and then 5 times 1 gives me the plus 5. Now I need to distribute that a value through to get it in standard form. So I'm going to distribute the negative 1 through, and I end up with negative x squared minus 6x minus 5 equals y. Make sure you distribute the negative all the way through in that standard form. Okay, now we're going to move on to 3.3 on number 24 on 3.3. This is about finding the vertex, and this is a very key important way of doing every one of these. So these are going to be critical. You'll notice a whole bunch of the story problems do this too. The key is going to be to find the vertex of a quadratic equation. So in this case, the quadratic equation is right here, this negative 2x squared minus 10x plus 13 equals y. To find this, the value is negative. Oh, the a value is negative, sorry. So this a value being negative says it's going to open down. So the vertex, if you think about a graph opening down, the vertex is the highest point of the graph, which represents a maximum point. So therefore, if it's going to open down, then you're going to have a maximum value at that highest point. That's going to be your max. So this one's asking whether you have a max or a min. Okay, now we're going to go over then and do negative b over 2a. This part right here, this negative b over 2a, is the most important part of figuring out what the maximum value is, what the vertex is, what the maximum height is, any of those sort of questions, is this negative b over 2a. That will give you the x-coordinate, okay, and that's also the axis of symmetry of the graph. So therefore, from the equation up here, I'm going to take the opposite of negative 10, which is positive 10, okay, and then I'm going to take 2 times the a value, which is negative 2. So 10 divided by 2 times negative 2 is 10 over negative 4, which equals negative 2.5 for x. Therefore, my x value, my x-coordinate, will be negative 2.5. That's the x-coordinate of the vertex, or the highest point. I need to plug that in to find the y value, which will be the high value, the highest point that the graph will ever meet. So I'm substituting in negative 2.5 in that original top equation. So in this equation right here, I'm going to substitute in the x value, which was right there, negative 2.5, and put it in this equation right here. So I just replace the x with negative 2.5. So therefore, negative 2 times negative 2.5 squared minus 10 times negative 2.5 plus 13 equals y. I multiply that out, add it all together, and y will end up being 2.5, or 25.5, sorry. So therefore, my answer will be vertex of negative 2.5 and highest value of 25.5. Therefore, it's a max. Moving on to set 4.1, number 36. This one is super important because kids are going to miss this on the test. Remember, if you can take an odd root of a negative value, that is possible. You can take the odd root of a negative value. Remember, you can't take an even root of a negative value, but you can take the odd root of a negative value, and it will always be negative. So now going back to the problem, I want to take the cubed root of negative 64 a cubed b 6. Well, I need to group those in groups of 3 because of this cubed root. That tells me I need in groups of 3. So I factored tree down the 64. That's 8 and 8. 8 factor trees down to a set of 3 2's, and you have 2 8's, so therefore you have a set of 3 2's and another set of 3 2's, which is 2 times 2. 2 times 2 is 4. Notice that because this was negative 64, this will have to be negative, and then it will be the 2 times 2, which is -4. Okay, now how many a's do you have under the root? Well, the cubed root of a cubed, a group of 3 a's, will come out as 1a. And then your b's, you have 2 groups of 3, so it should be b squared on the bottom. Then your top ends up being the cubed root of 21. Now, why did I leave the cubed root of 21 on top? Well, one is I don't have a root on the bottom, so that's okay. And secondly, 21 doesn't factor tree down into 3 common factors. In other words, 21 only factors to be 3 and 7. You won't have 3 3s, you won't have 3 7s, so you're just going to have to leave them under the root anyway, and you multiply them when you leave them under the root. So that's my final answer. Going to set 4.2, number 53. And these are kind of repeats through this part. You're going to see a lot of these that deal with the height using a quadratic function. All right, so we're going to use this, this that gives us the height over time. Notice -16 is almost always used as gravity. T squared is what you're going to use for gravity because it is pushing down at -16 feet per second squared. Your velocity is the upward thrust that is going to be 128 feet per second, and then its initial height off the ground is 6 feet. Okay, again, the key here is going to be to find the vertex. The reason is again, it's opening down. That's because of the -16. So the maximum height that it'll ever reach is going to be at the vertex. So I'm going to find the vertex by doing -128, that's the negative b, over 2a, 2 times -16. So -128, remember to take the opposite sign on the b. Don't forget to take the opposite sign on the b. -128 divided by -32 is equal to 4 seconds. So after 4 seconds, this thing's going to reach its maximum height. So I put in 4 in the original equation for t, and I end up with a height of 262 feet. So my maximum height is going to be after 4 seconds, and it's going to reach a maximum height of 262 feet. Okay, therefore 4,262 is your vertex. Your height after, so now you can start to do a graph. Your maximum point there is 4,262. I plugged in 3, 2, and 1, and then just realized that, hey, it is symmetrical. So after 3 seconds, the height was 246. After 2 seconds, it was 198. And after 1 second, it was 118. I just plugged in those values, 3 for t, 2 for t, and 1 for t, and ended up just figuring out the y values by plugging it into a calculator. So just put in 3 for t, 2 for t, 1 for t in that top equation right here. Okay, just put in your t values of 1, 2, and 3, and you'll end up with that 246, 198, and 118. Now, on a graph then, that would look like this. Now notice that the 5 matches the 3. It's symmetrical. So if it's at 3, 246, then it will be at 5, 246. If it's at 2, 198, then it'll be at 6, 198. If it'll be at 1, 118, then it'll be at 7, 118. Now, even though this is a launch of I think it was a launch of a cannon or something, the key here is that actually the coronavirus thing that's going around matches this same type of curve. It's a parabolic curve, and the number of new cases is supposed to max out after about 60 days. So therefore, new cases being reported. Now, that isn't saying that there won't be people still sick, but new cases being reported should look like this after a 60-day period. So that would mean 30 days after the initial amount, you'll reach your max value, kind of like this graph. And by the way, that's supposed to be around April 7th to 15th-ish, somewhere in there, is when we should max out and start going down the other side. Now that means the other side, though, we probably won't hit the bottom until middle of May to end of May. So that's just kind of mathematically what should happen with the coronavirus. Now, who knows what will actually happen, but that's the mathematical model. Okay, so it asked in this question, well, when will it reach 150 feet? Well, going by these, I know it's after 1 second and it's before 2 seconds. So I just guessed because it said, hey, estimate in part B when it will reach a height of 150 feet. I estimated 1.5 seconds. I plugged it in and I found out, oh, I'm wrong. It was 162 feet after 1.5 seconds. Still pretty good, estimate. Now I'm going to actually find the actual time it took, and I figured out that it was about 1.35 seconds. After 1.35 seconds, it was at a height of 149.6 feet. That's pretty dang close. So then I say, all right, now going down the other side, it's 1.35 seconds from 8 seconds, because that was the 0 second value that I will get. So I have to go from 8 minus 1.35. So that's how I got the 6.65. Again, I got the 6.65 by doing 8 minus 1.35. Again, remember on the graph, 0, 6 and 8, 6 are symmetrical points. So if I go from 0 up to 1.35, it's the same as going from 8 back to 8 minus 1.35, which would give us the 6.65. So those are the two times when the cannonball will reach 150 feet. Now going on to 4.2, number 62, this one gives you the height of water over how far you are from the building. This is a lot like the horseshoe problem, by the way. So your height of water is represented by y, and how far you are from the building is represented from x. Now in this case, they tell us that the firefighter is standing 57 feet from the building. So all I do is plug that in. I'm going to plug in 57 feet from the building and see how high the water will be if I'm 57 feet from the building. So I plug that in, and I end up with 26.3 feet. That's the height of the water from a person who is spraying it from 57 feet away. The height of the water will get to 26.3 feet. Now, the window, it says in the problem, because the bottom of the window is at 26 feet, and it is highly likely then that the stream is going to enter in through that window. If the bottom of the window is at 26 feet and your spray is going to go 26.3 feet, yeah, it's probably going to hit the right spot to go through the window. All right, step 4.5, number 53. It says solve this by graphing, factoring, and the quadratic formula. So here's our equation. If we were going to do it by graphing, again, I'd do negative b over 2a. So I take negative 4 over 2 times 1, which would be negative 2. That's my x-coordinate. I plug in that x-coordinate. So I end up with negative 2x squared plus 4 times negative 2 plus 4 to find the y-coordinate. Hey, when I find that y-coordinate, it ends up being 0. So therefore, I have a vertex that's at negative 2, 0. Well, this happens to be on the x-axis, negative 2, 0. Think about that. And it's the only 0 of the function. Therefore, negative 2 is the only 0. So even though I didn't graph the function, I used the graphing format of finding a vertex to show that it was at negative 2, which would be the only 0. I could also do this by factoring. If I was to factor, I would notice that this is a perfect square trinomial, meaning the first and last terms are perfect squares. And the middle term is double the square root of the last term. Let that sink in. First and last are perfect squares. The middle term is double the square root of the last term. So therefore, I can factor it into one set of parentheses. Squared, square root of x squared is x, square root of 4 is 2. One set of parentheses squared equals 0. Now this is equal to 0, not y, because I'm trying to find the zeros. And notice on the x-axis, when you're crossing the x-axis, your y value is 0. So I change the y to 0. Then I take the square root of both sides. I end up with x plus 2 equals 0. I subtract 2 from both sides, and hey, I only have one 0 at x equals negative 2. I could also do this by the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. All right, and we're going to plug in, obviously, those values of a, b, and c. So 4 is the b value, so negative 4 plus or minus the square root of 4 squared is the b value, minus 4 times, now that 4 is the constant, minus 4 times a, 1, times c, that's the 4 at the end, all over 2. Well, 4 squared is 16. minus 4 times 1 times 4 is 16. So therefore you have negative 4 plus or minus the square root of 0, which is 0, all over 2. Well, that's going to be negative 4 over 2, which is negative 2, which is the only 0. That was fun. All right, going to the next one. Chapter 4, review number 47. This is the baton thrown with an initial height of 6 feet and an initial velocity of 32 feet per second. Now, it's just giving you that. It didn't give you the equation. So it's going to give you an initial height. This is going to happen on the test. And then it'll give you an initial velocity. And then you're supposed to write the equation. Remember, you've got to put that negative 16 in to represent your gravity. So negative 16 t squared plus or minus the velocity, whether you're pushing down or pushing up. They're throwing the baton up, so it's going to be a positive velocity. And then plus or minus c being the height you are above the ground or below the ground. In this case, obviously, you're throwing it from a height of 6 feet above the ground. So my equation is going to be h of t equals negative 16t squared plus 32t plus 6. Again, we're going to have a maximum height because the a value is positive, and we want to find that maximum height by finding the vertex. Again, I'm going to do negative 32 divided by, the reason I'm doing negative is, again, negative b, don't forget to do the negative on the negative b, over 2a, 2 times negative 16. So therefore, we have negative 32 over negative 32, which is equal to 1. I plug in h of 1, solve it, and I end up with h of 1 being 22 feet. So 122 is the vertex. The maximum height this baton is going to go is 22 feet in the air. It's going to happen after 1 second that they throw the baton up in the air. Okay? So now to the questions. Will it reach 25 feet in the air? Well, no, its maximum height is 22 feet in the air, so it'll never reach 22 feet or 25 feet in the air. Will it reach 20 feet in the air? Well, yes, just before 1 second, just before it reaches its maximum height of 22 feet, and just after 1 second, after it reached its maximum height of 22 feet on the way down. So once on the way up, once on the way down. Number 18 is very similar, only this time x represents the linear feet of the toss. So how far away from you the toss of the horseshoe is going to be, and then y represents the maximum height of the toss. So it's still the same thing though. We just have this equation where x again is how far away from you the toss is. This is like the fire problem. And y is representing the maximum height. So using that equation, again, I want to find the maximum height. Again, I just use negative b over 2a. So that's negative 0.3, notice, divided by 2 times negative 0.01. So negative 0.3 divided by negative 0.02, when you multiply those, is equal to 15 feet. So this is 15 linear feet after you've tossed the horseshoe. The height of the horseshoe will max out, okay? So what is the maximum height here? So remember, you're kind of tossing it from 2 feet off the ground. How high will it actually get off the ground is what we're trying to find. We know that that will occur after 15 feet. So about halfway between you and the horseshoe length is probably 30. You're going to say, all right, at 15 feet, it's going to max out. Okay, so therefore f of 15 is 4.25 feet. Again, I just plugged those in on a calculator. And so 4.25 feet is the maximum height it's ever going to reach. So 15, after 15 linear feet, it maxes out at 4.2 feet high. Will it reach 8 feet? Well, never. It's only going to reach 4.25 feet. Will it reach 4 feet? Well, yes. Probably right around 14 feet of linear distance and 16 feet of linear distance. Because remember, at 15 feet, it's going to reach the 4.25. So probably on the way up at 14 feet away from you, and on the way back down at 16 feet away from you, it will reach that height of 4 feet. That's the review. Have fun taking the test.